No matter what technology you're using, the numbers are always going to go up and things are going to get faster. But as things get faster, they become less likely to meet the needs that you have. And Wi-Fi 7 is no different. In this episode of the Tech Field Day podcast, we discuss that Wi-Fi 7 will not meet the needs for future wireless users. Welcome to the Tech Field Day podcast, the only podcast that dares to be both on topic and on location. Each episode we bring together a group of experts in the IT field, practitioners who are willing to share their experience with our audience out there. Then we focus on a single idea, a key premise in the episode. Before we get started, I'd like to introduce our guests before we jump into the premise for this episode, starting with Drew.
Hey, everybody. Drew Lentz, wireless nerd on all of the social media. Been a veteran of the wireless industry for a minute now, and now doing a whole bunch of fun consulting focused on Wi-Fi, transitions to Wi-Fi 7, private 4G, private 5G, all the good wireless stuff.
Hey, I'm Rocky Gregory. I am under Bionic Rocky on all the socials, and I've been doing enterprise-focused wireless for about 25 years now.
Birds of a feather. Thank you, Tom. I'm Ron Westfall, Research Director here at the Futurum Group, and I focus on communication networks, including Wi-Fi, including private 5G, private networks, and basically the mobile ecosystem, the wireless ecosystem, and all things related to it. Thank you.
And of course, I'm Tom Hollingsworth, event lead for Tech Field Day, which is a part of the Futurum Group. Let's jump into the premise for today's episode. No technology is future-proof. If it was, we'd still be using ArcNet, but we're not. We're using wireless. In fact, I don't even know anybody that uses Ethernet unless they absolutely have to. But Ethernet is pretty much a baked standard, unlike wireless. Wireless, it seems, is constantly evolving. We've gone 802.11a, B, G, BE, OMG, WTF, and now we're just calling them by numbers because marketing is better. Wi-Fi 6, Wi-Fi 7, Wi-Fi 6E, maybe. But no matter what you call the standard, it's not always going to be perfect. So for this episode, the premise is that Wi-Fi 7 isn't going to meet the needs for future wireless users. All right, before we get started, we have to, at least mention that at the time of this recording in May of 2024, Wi-Fi 7 is barely a standard. Like the Wi-Fi Alliance has basically said they're going to allow people to start putting 7 on there, but there aren't a lot of devices out there that are available that have Wi-Fi 7 capabilities. So I want to open the floor up to everyone here. What is it about Wi-Fi 7 that we already know isn't going to meet the needs of things that haven't even been developed yet?
Well, it doesn't go to 10, right? And 10 is the top of it. So unless it goes to 10 or 11, it's always going to fall a little bit shorter. Thank you. Have a nice day. No, there's a lot to it, but I love where it's going. It's interesting to see. We ran into an issue at the WLAN Pros conference at WLPC this year where we're like, oh, this is great. We can connect to Wi-Fi 7 and we can do MLO and this is phenomenal. But they only put a 2.5 gig port on the back of the access point. So what's good in having all that data if you can't take it out to the port side? Or what happened to us was what happens when your wireless connections are stronger than your wired connections. That was an interesting issue to get into. So I don't know. What do you think, Rocky?
Yeah, I agree. In the enterprise, especially, there's a push for what's new, what's sexy. 7 is better than 6. We need to go get 7 APs, but on the backside, you've got switches that have been there 15 years. And so you're overrunning it. The other side of it, the other piece is people will use as much bandwidth as you give them, and it will never be enough. We're all on DSL. Before that, we're all on dial-up. And it's never been fast enough. Gigabit, not fast enough. So it will be faster, yes. It'll enable more apps, yes. But no one's ever going to be satisfied.
And to add to that, I am anticipating that there needs to be some enhancements to the standard for anybody who's deploying access points and want to optimize the wireless experience. And that includes capabilities like customizable tri-band radio configurations that span the 2.4, 5, 6 gigahertz bands, and as a result can right size coverage all the more better. And what I'm referring to is, the capability that allows a organization to implement, for example, combining the 5 gigahertz and the 6 gigahertz channels in an optimal way. As we know, currently there are many countries and regions that must sacrifice the lower 6 gigahertz channels. And that is basically sacrificing about a third of the overall 6 gigahertz channel. And so, who wants that? Because the traditional filters are simply preventing the use of adjacent 5 gigahertz and 6 gigahertz channels. And so, that is a significant trade off. You're basically, if you just go with a standard Wi-Fi 7 implementation, you can end up sacrificing up to 30% of the capacity. And so that is coming up short. So I anticipate that access points and the overall implementation will need to have this type of capability. We're seeing companies like HPE Aruba advocating this type of approach in order to compensate for this built-in concern, if you will. And so that is, one thing that I believe needs to be addressed or accounted for in terms of, Wi-Fi, Wi-Fi 7, and what more needs to be done to really make it zing for the customers out there.
So I'm going to push back on one thing, because I mean, you guys all have brought up really interesting points that, there's never enough bandwidth in the world, right? If I had a gigabit pipe running into my house from my ISP, it still wouldn't be enough because my kids would need a terabit pipe. But when you look at the hardware that's inside of these devices, it really hasn't generationally evolved much. My devices, whether it's my MacBook or my desktop, still have gigabit Ethernet ports. In fact, it's very rare that you find any kind of a desktop port that is a 10 gig Ethernet handoff. I mean, the Mac Minis have one, but they're using those kind of in a very specialized form factor, like basically as digital media servers, where people are having to push and pull like large video files and things like that. They're not intended for like day-to-day use. What is it about Wi-Fi that's causing it to overrun the other standards? Because on the same token, I see a lot of access points that have mgig as a function, but I don't see a lot of people that are like, oh, well, we need to start putting 10 gig Ethernet ports on these access points. What is it about the Wi-Fi standards that's just causing this to balloon?
I think a lot of it also has to do with latency, right, and quality of experience. If you drop the amount of latency and the amount of time that it takes to deliver all of that data to a wireless client, regardless of what it's connected to on the Ethernet side, it's going to increase that quality of experience for anyone that's using it. And especially if you're in an environment where it's a wireless to wireless connection. If I'm sending data back and forth to someone on the same access point or on the same network, on that AP, then it makes a lot of sense. If I'm doing video editing across multiple devices or servers, assuming that they would be connected via wireless, then it can be kind of cool. But still, it all comes down to that Ethernet port. And I think that that's where the issue remains: is are people willing to make the investment in the Ethernet that provides the power and the data capability to that access point? And if they are at that significant level, I mean, what are they using it for that's requiring that much data? And is that a good solution for them at that level? Because you're right. I mean, you get to a certain point and if I can consume 10 gig per second on my iPhone, does that just mean that TikTok loads faster? How much of that has to do with DNS to begin with? So it's like, at what point is it a rate of diminishing return to have that much speed delivered over wireless? And that's where I look at resource units, and that's where I look at Wi-Fi 6E going in, 6 going into 6E, going into 7, now moving into 8, is that the ability to deliver small amounts of data very rapidly and big amounts of data when they need to be delivered with that extremely low latency. Latency to me is what's going to drive QoE. It's not going to be the speed. It's going to be, if speed is, if we have all the speed in the world, how does that help me? How does that help me as an end user of some of these devices? So I don't know, but to what you're saying, Ron, I think, it's interesting. The 6 gig conversation, right, with 6 gigahertz, for the areas that are affected by people who haven't adopted 6 gigahertz, India and all these other, countries that still haven't jumped on the bandwagon with some of them yet. It's fascinating because you do lose that amount of of capacity, but only in the areas that are affected. And I don't think that the chipset manufacturers and the AP manufacturers should turn around and change their model based on what few have not adopted yet. But it reminds me of the article I read just this past week with, in India, where the Carriers Association was trying to outlaw any 6 gigahertz devices from coming into India, because they said, hey, you can't sell those on Amazon anymore. Like the whole signal jammer thing that they're trying to push across the globe. We don't want people buying access points that are capable of 6 gigahertz because it hasn't been ratified in that country yet. So I think that there is that trade-off. The manufacturers have to do, whatever is in the capacity of the capability, if you will, of what spectrum is available to them. But I think that's where that software defined radio stuff really comes into play. It's like, okay, well, if your country can't use this, then all good, but don't limit what we can do here because of what your country hasn't done. So it's a fair trade-off. But Tom, I did want to point out, you mentioned that not a lot of the APs have gone through these iterative changes, not just with the gigabit port, but if you think about the amount of memory, the amount of compute, and the amount of resources that are available on the hardware themselves, not a lot has changed. And it's always been that race to the bottom. How do you create the most cost-effective, efficient access point to just deliver, convert data from wired to wireless? But now, like Aruba's announcement, super, super cool to see what they're doing, loading, almost doubling the amount of memory that's on the device, and like totally jumping, by orders of magnitude, the compute power on those APs, signaling that, the shift of what they're trying to do compute wise is pushing even further out to the edge and down to the access points. I think we're in a really cool time where we're starting to see that, where those access points went from being these big beefy APs to being the don't worry, we have a controller to manage it all, to don't worry, we're going to stick it on the cloud, to now, what's old is new again, going, how do we bulk up these APs to put some serious horsepower on them? Not just, well, in the name of AI, if you will, but at least there's going to be some really cool benefits, I think, to come of that.
And yes, the mention of AI, I think, definitely is underlying this entire conversation. Yes, there are new AI-enabled capabilities that can be put on access points to quite simply optimize things like energy efficiency. Being able to throttle down the access point at different intervals according to the amount of traffic that's on the network that's affecting that specific access point or sets of access points. And also, yeah, I think it goes back to Tom's point about, what is it on the content side or the workload side that it will warrant, yet more speed. When is enough is enough. And I think that there's warrant for these investments on the part of, the access point manufacturers, the silicon vendors, and certainly, all the partners that are involved, because AI workloads are going to become increasingly predominant. And that it will relate to both, the Gen AI workloads, the inferencing, but also in terms of, what can be deemed, some traditional AI capabilities involved with that automation to improve, again, the latency. That's really, I think that's a fair point, that it's going to be critical to have improved latency and quality of experience. And the speeds and feeds will always matter, but they won't be as, I guess, vital in terms of, say, the decision making and what access point to implement and so forth. And so, yeah, I think that is a good way of looking at what's new and different. And a lot of it is quite simply related to AI.
I want to just jump back on that topic real quick, because at Wi-Fi Now in Sarasota a couple of weeks ago, the group from MediaTek was out there, and they were talking about the chipsets and what they're envisioning from an AI perspective on happening on their routers, and as they push it further to the edge. And when you talk about, Tom, your point about how much is too much, again, to me, it all goes back to QoE, right? Quality experience is going to be the ultimate determining factor on how well a network is working, because it doesn't matter if it's up or down. It matters, can you actually access it in a way that you need to. And with AI, even the generative AI stuff and the chat GPT stuff, like when you ask it a question, you want it to respond immediately. You don't want to sit there and wait, like, wait for the spinning ball to figure out what it's doing. That's typical computering. Now you want it to deliver that automation or that answer immediately. And one of the things that they brought up was, imagine if your home router or your Wi-Fi access point, from an advertising perspective, imagine if that access point now understands who you are as a user profile, what you do, where you go, et cetera, and the advertisements that are generated for you on your web browser aren't coming from a server farm somewhere with a graphic and an image, but they're actually being generated based on your user profile on the access point, or on the home router or as close to you as possible. Now the time for response for those advertisements to take place isn't Drew hitting the AP, hitting the switch, going out the core network, grabbing it, bringing it all the way back. It's Drew to the access point and an advertisement immediately delivered. And I think about, back in the old days when everyone figured out you could hit what is like F7 on your web browser, or F12, and you could see, all the DNS requests that are made every time you load a web page. If you limit the amount of time, if you decrease the amount of time to serve those advertisements whenever you open Reddit or or your news website or whatever it is, now your quality of experience is going to be much higher, because you're not waiting for the DNS request, you're not waiting for any of that information to take place. It's all being generated on the access point because of that beefier power and that super low latency. And I thought that was, hearing that, I was like, mind blown. And I don't want my AP really knowing who I am, but in the day when that happens, imagine something like that for a home user, and then how that transpires in enterprise.
Yeah, it's interesting. It's kind of the "give me convenience or give me death," to quote the dead Kennedys. Am I happy enough with the convenience of getting all of those ads right away to ignore the fact that this little box in my house is going even further than the Amazon Echo as far as what it's storing locally about me, right? So I think that's the smarter that we make stuff on the edge by adding AI, the faster stuff happens, but the creepier it is, right? If I open the box to my router and it says, "Oh, by the way, I'm going to listen to everything you say and I'm going to serve you ads directly." That's creepy as hell, especially the stuff I serve. I don't want that on a box in my house. So, like, you know, it, yes, it'll improve speeds. So, is that enough? Is that enough convenience to make something like that acceptable? And we do it on the web now, so maybe it is. Maybe it is. But is it the next time that MediaTek, not that they've had, an incident, but the next time that Linksys has an incident, D-Link has an incident, someone jumps onto one of my Internet of Crap devices and jumps into my router, pivots into it, is that data something that is stuff that I'm comfortable being protected on a little home device running TinyBox, right?
And how does that play out in the enterprise, right? I mean, if you think about maybe not delivering advertisements, but delivering authentication, delivering intranet. Does anyone use the term intranet anymore? Intranet feeds, like any localized data, caching for Salesforce or caching for Workday or whatever it is. How can things like this be leveraged to deliver very quick answers, or leveraging AI on the actual access point to deliver something that normally would have taken a large amount of time? Because I think, again, this, I don't want to do the Bill Gates reference, but it's the amount of speed that we have, the amount of throughput that we have right now delivered within an appropriate amount of time is always going to be expanding. But the things that we're doing with it haven't really changed that much. We're sending text, we're receiving text and images. I mean, that's like at some point, it's the banana, it's throwing a banana down a hallway. It's like, well, what point is it? It's so much that it's, now if we're unencumbered by that, if we're unencumbered by the speed, a gig, 2 gig, 5 gig, 10 gig, whatever it is. I mean, we did on the last AP, on that Ubiquity AP that we did at WLPC, we were negotiated at 2.8 gigabit per second using MLO, using 5 gig and 6 gig combined. And it was like, what are we going to do with 2.8 gig? You can get a lot of stuff really fast. But again, when you talk about the hardware vendors and what they're doing to take advantage of it, I love the idea that Aruba has added not just more RAM and more memory, but also more functionality. Now they're going, okay, well, if this is a platform, let's, they loaded on the location services, 802.11az. They're going out in different ways where they're starting to combine more IoT along with BLE, along with Wi-Fi, along with multi-link operation. Now it's using the access point as a platform more than just using the AP. And I think that that's great. I'm just waiting for now. When did the switching teams come out and say, no, don't put it on the AP, put it on the switch, because it has to connect to the switch anyway, and it's probably more effective to build a big, expensive, beefier switch so that all the APs can reference the switch. I mean, is it going to start to go back again like it did with the cloud? Like it started to go up to the cloud and now it's coming back down? Is that something that we see in the future?
It's a local CDN, right? Your AP becomes a local CDN, and in the enterprise, were I in the information security space, I'd be saying, nope, nope, nope. I don't want anything living there. I want one point of ingress, egress, the back of the controller, and that's it. So I think it's cool, it's nifty for, my home, but I don't want that going on in my enterprise where I've got IP everywhere. I want that IP consolidated, not pushed out to the edge of the network.
Yeah, and I think these are excellent points because it points to context. As we know, it's not unique to access points or Wi-Fi 7 or Wi-Fi 6 technology. It's about the customer. It's about the use case. And so, yes, there will be variants in how they need to be implemented. There will be many enterprises that will welcome an intelligent hub type of implementation for the very reasons we outlined. It can improve everything from security to energy efficiency to, again, literally running a container on an access point in order to aggregate more information at the edge in a more intelligent way and rapid way, quite simply. And I think it also aligns to the point about, yes, access points are going to be integral to wireless implementations, but also they have their inherent limitations, and that is, for example, the use of private wireless in order to accommodate the mobility requirements that can come up in many large enterprise settings, such as stadiums, such as manufacturing sites, and so forth. So I'm also keen in looking at how Wi-Fi is more blended and managed, at least, or administered with, say, private networking capabilities, the private-public combinations, if you will, because as we know, there are many scenarios where Wi-Fi makes sense at the headquarters, but you need, a private 5G implementation for the fleets, for the far-reaching locations and so forth. And so this is something that is just going to fuel, this journey that I think will just make it all the more interesting. How Wi-Fi 7 plays a key role in all this, that can also deliver its own advantages and also work more effectively, ultimately, with other technologies.
You've definitely spoken about how the content consumption model has changed. It used to be that everything was a mainframe and we all went to the mainframe, and then we'd had client server with a lot of east-west traffic and not a lot of north-south traffic. And that's what we as networking professionals refer to it as, meaning north-south headed to the internet and east-west headed between servers inside of a LAN. But most of the users in the rest of the world don't even know that distinction. To them, it's fast, right? Like if you just go to fast.com, like it just gives you a number, right? Most people don't understand the difference between my access point being fast versus my Ethernet being fast. And most of the time, what are they going to do anyway? Well, if things are running slow, they're going to bail back to their 5G LTE radios because those have fewer things in the way getting to their point of content consumption, because most everything is in the cloud. I mean, as we're recording this podcast, we're not using local video cameras to do it. We are using a cloud service that is administered through a web browser. And that's how most people do things now, is they consume their whatever they're interested in. So yeah, you can create a CDN locally and accelerate some of that, communication, because I can fetch data from it faster. But most people now are not consuming their content on a traditional desktop PC or even a traditional laptop PC. They're either consuming it on an iPad or they're consuming it on a mobile phone. And just to that point, I mean, the discussion about Wi-Fi 7 being fast enough or being able to meet the needs of future consumption models, all we have to do is look at the latest generation of the iPad, which was just announced as of the recording of this podcast. It's running an advanced M4 processor. And everyone says, this is the fastest thing that Apple's ever made. Too bad they put iPad OS on top of it. And that's how we're seeing this now. Is it doesn't matter how fast your network connectivity is, it's still the way that we consume the stuff through that OS, that is, or through the network connectivity, that's dictating how quickly we are able to interact with things. And I think that that is one of the ways that LTE and 5G have finally caught up to Wi-Fi. It used to be we had to have Wi-Fi because the cell networks were so crappy. Like you wanted to go find a Starbucks so you could hop on the free Wi-Fi to be able to do stuff. Now there's even a setting in iOS devices so that if your Wi-Fi is crappy enough, your phone will fail back to a 5G signal because it's a better quality signal. So are we ever going to get to a point where Wi-Fi 7 or Wi-Fi 8 or whatever we're going to call the next revision of it is fast enough that we don't have to compete with 5G? We can say this is good enough for what we need to do now.
I think we may get there, but it's informing the end users that it's enough, right? So in the very large enterprise that I most recently came from, our most critical app, our mission critical app was fast.com, because every senior director would sit down and do a speed test and it's too slow, so my people are being slowed down. Well, no, your people can do their jobs and they can do them very well. So it goes back to as much bandwidth as you give them, they're going to use. But it's also looking at that perception of somehow informing your end users that it is enough, because the only metric that matters in Wi-Fi is the person sitting in front of the screen. Is it good enough for them, or are they happy with it? In the enterprise, that's all that matters. So if we give them all this speed and they find ways to use it, all the better. But in reality, to your point, I think, Tom, they don't really need it. They have the perception that they need it, and that fast.com is faster on my Linksys at home. Why can't it be that fast on the $50 million Wi-Fi network in my enterprise?
And I think, again, going back on QoE, I think back, 10, 15 years ago, remember Interop, remember Networld Interop? So I used to do Wi-Fi 101 at Interop, and it was standing room only every time I did it because everyone wanted to understand what Wi-Fi was. And I had this moment at the beginning of every single one of my sessions, and I would ask everyone to get interactive. I'd say, hold up your hands if you're on the cell network, hold up your hands if you're on Wi-Fi. Okay, if you're on Wi-Fi, are you on 2 gig or are you on 5 gig? If you're on the cell network, are you on band 42, 43, 48, 52? If you're on band 800, raise your hand. And everyone, looked perplexed. And I said, the point of this entire conversation is that it doesn't matter because no one cares. You don't care how you're connected. You don't care how your device is connected. What you care about is your quality of experience. And now, from an orchestration perspective, if you think back on how Wi-Fi 7 interacts with, how Wi-Fi period interacts with private wireless, how it interacts with 5G. That's why, to me, that Khajiit announcement with Khajiit and Cisco, or Khajiit and Meraki, talking about how they're bringing management of Khajiit IoT devices into Meraki Cloud, it was fascinating because I was like, okay, here it comes, because Khajiit's known for their neutral host stuff as well. And it's that idea that someday there's that dashboard that is just the wireless dashboard, not the Wi-Fi dashboard, not the 5G dashboard, but just the wireless dashboard. It's giving you the amount of capacity that you need with the latency that you need to do what you're trying to do based on your application awareness on the network. If you're trying to send a tweet, it gives you this much. If you're trying to stream video, it gives you this much. And it does this one on 4G, it does this one on Wi-Fi, it does this one on LoRaWAN, whatever it is. It's the idea that we're moving to this convergence point where all of those things should be controlled by one. And that's where that whole AI conversation comes in, because it's like, well, if I've got to manage, BLE, and I have to manage Wi-Fi, and I have to manage 5G, and I have to figure out how to slice that network to give the user what they need for what they're doing, no network administrator is going to be able to control that and orchestrate that without some level of sophistication. It's bad enough now with Wi-Fi 7, we're doing multi-link optimization, which is great. MLO is great. I love it. But look at what Wi-Fi 8's doing, where you're taking two disparate access points and you're getting 5 gig from this one and 2 gig from this one, and I'm sending 2 gig out that one, and I'm receiving it on 6 gig over here. we're getting to a point where network administration, troubleshooting, etc., is not going to be able to be easily done, I don't think. And having the smarts, if you will, I got the smarts real good, the quote from Urban Cowboy, having the smarts to be able to do that on the access point level or on the switch level without leaving the actual building or the room or the submarine or whatever it is. That's the part that's encouraging to me, because it's like, if you have all these APs that are trying to orchestrate between each other, but you don't want that data going northbound, then what? Because that QoE is going to be absolutely aware, or it's going to be subject to your network being aware of what to give you, when to give you, and how to give it to you in the shortest amount of time. So
Yeah, I agree. Kind of entire connectivity neutrality, right? So I don't care. In the end, in the enterprise, in my experience, it's always the Wi-Fi that's the problem, right? And so my engineers would go, we'd get the call, the Wi-Fi stinks. Here, let me look at your phone. Maybe you should turn on the Wi-Fi. It might work better. So, if we can abstract that and give the right experience at the right time, I don't care what network it goes over to, but it goes over. But to your point, Drew, I do need to have that, oh God, single pane of glass. Sorry, I hate it. I'm sorry. I do need to have that. That's my user experience if they're sitting in HQ, regardless of how they're connected.
Yeah, I think one thing that can help with the complexity, the disparate implementations, is again our new friend, or not new friend, but popular friend AI, which can, I believe, along with machine learning capabilities, help automate some of that orchestration, that single pane of glass type of implementation. I don't like the term either, but it gets the idea across. It's just a common shorthand reference for us to understand that we just need that streamlining of how to better administer and have governance of our networks. And I think it's always going to be this dynamic blending, because for example, the 5G connected laptop use case, business case, pretty much is predicated on public Wi-Fi security is an issue, especially if you're in the government or national security, or any organization or enterprise that has high security requirements. That's going to matter. And so, for example, if I'm not mistaken, government subcontractors, they don't want them using their public Wi-Fi ever on any laptop that's issued, and that it goes to common sense. And so I think this is just an example of how it's just going to be predicated on the use case, the requirements of the customer, and we're going to see both types of major implementations, but also other forms of wireless technology. We touched on already Zigbee, Bluetooth, certainly, all of them coming under an umbrella when it comes from an enterprise perspective, basically being more intelligently administered, and also being able to use things like proactive or predictive analytics to better anticipate these issues that have been succinctly touched upon.
Well, as you can see, the genesis of making faster and faster speeds of anything always has a lot of other factors that go into it. Whether it is the direction that your traffic is traveling, whether it's the applications that you are accessing, or realistically speaking, whether or not the people who are in charge of the budget want to see the number keep going up and up and up. You have to understand the way that your users utilize your connectivity. You have to understand where your data is stored. Is it something that is local? Is it something that is remote? You have to educate your users about why things look faster in certain places than they do in others. And you have to make sure that you have all of this documented in such a way as to be able to send it out very quickly when someone comes knocking on your door and wonders why their Netflix is faster at home than it is in the office. And if you do that, I think you'll find that Wi-Fi 7 will be good enough for what you need now, unless someone really gets into VR headsets, in which case all bets are off and we're going to need Wi-Fi 9 by that point. That'll just about do it for this episode of the Tech Field Day podcast. I'd like to ask our guests, if people want to follow up more with some of the things that you've been discussing and see some of the content you created, where can they go to learn more, Drew?
At Wireless Nerd or wirelessnerd.net, or jump onto the Waves podcast so you can hear me talk about this kind of fun stuff every week.
Bionic Rocky on Twitter, and then bionicrocky.com, which is my very seldom updated blog.
Yeah, you bet. The Futurum Group, we certainly have our website. Tom and I usually co-host what's called the 5G Factor, so please bookmark that on our website. But also in terms of X-Twitter, I'm at Ron Westfall DX, and I'm also on LinkedIn.
Awesome. And if you'd like to see more great wireless discussions like this or any other things that revolve around mobility, make sure you go to techfieldday.com and click on the link for Mobility Field Day 11. It is our upcoming mobility focused event that is going to have conversations around a lot of these topics and many more. And you can also check out youtube.com/techfieldday for lots of great mobility action. Thank you for listening to this episode of the Tech Field Day podcast. If you enjoyed this discussion, please make sure that you subscribe to our YouTube channel and you leave a rating and a comment so that everyone knows what we're all about here. This episode was brought to you by Tech Field Day, which is a part of the Futurum Group. We are excited to bring you more great conversations like this on a weekly basis. Make sure that you check out techfieldday.com/podcast for the latest episode. Until then, we hope that you have a great day, and we look forward to having more great conversations in the future.